Starting from a common point, show the following process in a PV diagram. There are two problems I have given, first one and second one. First one is just a process of expansion. In this one, it is all the process of compression. Let's solve the first one, how we will get a PV diagram. Let us write for this particular expansion process. It is pressure, volume. The first A, it is constant pressure heating. This constant pressure heating, this is state 1 and state 2. Constant pressure heating, this is constant pressure, P1 is equal to P2. This is expansion. In a heating process, volume increases. This is constant pressure process. As it is heating, volume increases. The second process, it is isothermal expansion process. In the isothermal expansion process, they said starting from a common point. Therefore, I have to write this curve to the state 1 itself. Therefore, this becomes state 2. And this is the path. And governing law, it is PV is equal to C. Isothermal expansion. Pressure decreases, volume increases. Next process, it is polytropic expansion process. This is starting from a common point. This is state 2 following a path, and governing law of PV to the power of n is equal to C, where here it is n is a index of expansion. D, constant volume cooling. This is constant volume cooling. In a cooling process, look at this constant volume cooling, where pressure decreases. This state volume is held constant. In a constant pressure heating, volume increases. Constant volume cooling, where the pressure decreases. The next we will go to all the four compression process. State 1, where constant pressure cooling. In this constant pressure cooling, volume increases. Constant pressure cooling 1 to 2. Next process, it is isothermal compression process starting from a common point. This is state 2 following a path. Governing law, it is PV is equal to C. Next process, polytropic compression process. This is polytropic compression where pressure increases and volume decreases. This is state 2 following a path. Governing law PV to the power of n is equal to C. Here n is index of compression. The last process is constant volume heating. Volume remains constant and pressure increases. This is the process, and this is volume is held constant. One is the expansion and another one is the compression. This is constant pressure heating. Constant pressure heating comes under expansion. Constant volume cooling comes under expansion. And constant pressure cooling comes under compression. And constant volume heating comes under compression. Next problem is consider a gas examined in a system. The initial is being 210 kilopascal and corresponding volume is 0.0504 meter cube. Calculate the work done when the volume of gas increases to 0.15 meter. We have a two, this one is by heating at constant pressure and another one is by pressure varies inversely with volume. Let us write the data as whatever we got in the problem. The initial is being 210 kilopascal. The one is 210 kilopascal, like 2 into 10 to the power of pascal Newton per meter square, and corresponding volume is 0.04 meter cube. V1 is 0.04 meter cube. Calculate the work done when the volume of the gas increases to, that means the final two, there are two states, state 1 and state 2. State 1 we know pressure and volume, state 2 we know the volume. It is final volume is 0.15 meter cube. We have to calculate the work done. How much is the work done for two cases, that is constant pressure, and another one is pressure varies inversely with volume. For these two cases, we have to calculate the work done. Let us calculate the first one by heating at constant pressure process. By heating at constant pressure process. Let's write the PV diagram. PV diagram. Constant pressure process. It's a horizontal line. This is constant pressure heating, that is expansion 1 to 2. This is the heating process. Change of state from 1 to 2. Constant pressure. This is corresponding volume. Here it is V1, and corresponding volume here it is V2. Area below the curve in any PV diagram, it is work done. This is work done. We have to calculate that. The corresponding pressure is P is equal to P1 is equal to P2. We know that uh, work done for a constant pressure process is calculated by integral 1 to 2 PdV, assuming all the process reversible. We have the expression for constant volume after deriving this P into V2 minus V1. The unit will be in Joule. Joules means what? Newton meter. When you substitute pressure in Newton per meter square, volume in meter cube, then you will get the answer in Joule. This is the work expression for constant pressure process. Let us check what are the values we got. P is equal to P1 is equal to P2. Yes, it is known in the problem. V2, yes, it is given. V1, yes, it is also given. Therefore, W1 to 2, pressure is 210 into 10 to the power of 3 kilo Pascal. Kilo 10 to the power of 3 Pascal is Newton per meter square. And V2 is 0.15 and V1 is 0.04. Therefore, W1 to 2 is equal to, you get you get 23.1 into 10 to the power of 3 joules, or else you can write 23.1 joules. This is the answer for W1 to 2. It is by heating at constant pressure process. The second one, that is by where pressure is varying inversely with volume. Inversely with volume. That is, pressure is inversely proportional to volume. If I remove the proportionality symbol, you get a proportionality constant, that is P is equal to C by V. If I rearrange the term, that will become PV is equal to C. If you recall, this is the governing law. PV is equal to C. It is the governing law for which process? Isothermal process. Isothermal process. That means indirectly, instead of telling it is isothermal process, they have said pressure is varying inversely with volume. If I rearrange the term, I got this PV is equal to C. Therefore, PV is equal to C. It is the governing law for isothermal process. Let me write the PV diagram. Pressure, volume, and I have to check whether it is a compression or expansion. And with the volume, V1 is equal to 0.04 meter cube, and V2 is equal to 0.15 meter cube, and pressure P1 it is 210 kilopascal. I don't know other pressures so that I can identify whether it is a compression or expansion by looking at this volume. Volume is increasing, therefore it is an expansion process. Therefore, state 1 to 2, it is expansion process. Expansion process. Governing law, it is PV is equal to C. Corresponding volume here it is V1, and corresponding volume here it is V2. Area below the curve is work done. Corresponding pressure it is P1, we know 210. But in the previous problem, P1 is equal to P2, that is constant pressure. But here, P2, I don't know. But since it is isothermal process, you know the work done that is P1 V1 ln V2 by V1. Is this data sufficient to calculate the work done? Let us check. P1 it is known, V1 it is known, V2 is also known, V1 is also known. No need to calculate the final pressure. Therefore, W1 to 2 is equal to P1, that is 210 into 10 to the power of 3 into V1. V1 it is 0.04 ln V2 0.15 divided by V1 is 0.04. Now W1 to 2, after substituting all the values of pressure and volume, you get 11.10 into 10 to the power of 3 joules. Or else you can write 11.1 kilojoule. This is the work amount of work in uh, isothermal conditional calculation. How to calculate pressure, final pressure. It is not given in the problem, but they may ask final pressure, that is P2. You know the governing law, PV is equal to C. It also obeys that P1 V1 is equal to C and P2 V2 is equal to C. And I can write based on these two, P1 V1 is equal to P2 V2. Therefore, P2 is equal to P1 V1 divided by pressure we know P1 into 210 into 10 to the power of 3 and V1 it is 0.04 and V2 it is 0.15. Therefore, P2 you will get around 56 into 10 to the power of 3 Newton per meter square. Look at the P1 210, that is this is 210 and this is 56 kilopascal. Yes, this is the solution. Now here is compressed. The process is compression process. Divide the data. The process is compression process. I'm solving a question here. From 1 bar P1 1 into 10 to the power of 5 Newton per meter square, comma V1 zero point 0.1 meter cube to 6 bar. The final pressure is 6 bar, that is P2 6 into 10 to the power of 5 Newton per meter square. In a piston cylinder device, according to law, PV to the power of 1.4 is equal to constant. Based on this, I will tell the process is polytropic process. And you know that for a polytropic process, work done is P2 V2 minus P1 V1 divided by 1 minus N. Let me write the PV diagram. Pressure and the volume. It's a curve. It is curve in a PV diagram. As it is a compression, therefore pressure increases, volume decreases. Therefore, this will be the state 1 and the state 2 by following a path. And governing law PV to the power of 1.4 is equal to constant. Corresponding volume it is V2 and this volume it is V1. Area below the curve it is work done W1 to 2. Corresponding pressure it is P2 and this pressure this is P1. Therefore, in the problem P1 is known, V1 is known, P2 is known, N is known, only the unknown term is V2. Therefore, let us calculate that. We know PV to the power of 1.4 is equal to constant. Therefore, I can write P1 V1 to the power of 1.4 is equal to constant and P2 V2 to the power of 1.4 is equal to constant. Out of this, I will take the next second. Last two P2 P1 V1 to the power of 1.4 P2 V2 to the power of 1.4. Therefore, let me write this P1 by P1 by P2 is equal to V2 by V1 whole power of 1.4. Therefore, V2 is equal to P1 by P2 whole to the power of 1 by 1.4 into V1. Substitute this, you get V2. The V2 value will be 0.0278 meter cube V2. 0.02878 meter cube. Now substitute this V2 to the W polytropic process. W1 to 2 is equal to V2. V2 is 6 into 10 to the power of 5. V2 0.0278 minus P1 1 into 10 to the power of 5. V1 that is zero point 0.1 divided by 1 minus 1.4. W1 to 2 is equal to minus 16.7 into 10 to the power of 3. You get joules or Newton meter. In another way, you can write minus 16.7 kilojoules. That negative sign indicates the process is compression process. You know the sign convention of work done on the system it is minus, and work done by the system it is positive. As it is a compression process, based you can verify your answer, you will get a minus. This is question A, where it is follows PV to the power of 1.4 is equal to constant. Next question B. If the compression is carried out hyperbolically, now this is a new term for you, hyperbolically. I already said another name for isothermal process is hyperbolic process. Therefore, given is it is isothermal process. Question B, it is isothermal process. Between the same initial state and final state as in A, what is the work done? Now our task is to find that they have given hyperbolically. Another name for hyperbolic process, it is isothermal process. Isothermal process or constant temperature process. And in a PV diagram, it is also curve compression process. This is the curve compression process. That is here one pressure variables, but the governing law of the curve is PV is equal to C. Hyperbolically, the governing law will be PV is equal to C. Previous A, it is PV to the power of 1.4. As it is given hyperbolically, N is equal to 1 here. Therefore, area below the curve, it is work done corresponding volume here it is V1, V2. Area below the curve, it is work done. We have to calculate that. Corresponding pressures are P1 and P2. And we have to find the V value, V2 value. What is the work done for a expression for hyperbolic process? W1 to 2, it is P1 V1 into ln V2 by V1, or else you can calculate P1 by P1 is ln P1 by P2. Now in this problem, we know P1 that is 1 into 10 to the power of 5 Newton per meter square, and V1 we know V1 it is 0.1 meter cube, and P2 they have given 6 bar, 6 into 10 to the power of 5 Newton per meter square. And we calculated V2 here, V2 based on this, that is if it is a polytropic process. Therefore, now we have to calculate V2 for a PV is equal to C. For using this, we have to calculate V2. But I can use either this expression 1 or this expression. If I look at the second expression, where it is in terms of pressure ratio, that is P1 is known, V1 is known, P2 is known, P1 is known, I can calculate using the second formula, that is P1 1 into 10 to the power of 5, V1 that is 0.1 ln P1 1 into 10 to the power of 5 divided by 6 into 10 to the power of 5. We will get W1 to 2 as minus 17.91 into 10 to the power of 3 joules, or else it is in kilojoules if you write minus 17.91 kilojoules. Now minus indicates it is a compression process. Now in the problem they may ask you an additional find the final volume. How to find the final volume? You have a isothermal process governing law PV is equal to C. You can write P1 V1 is equal to C, and at the same time P2 V2 is equal to C. Therefore P1 V1 is equal to V2 V2. Therefore V2 is equal to P P1 V1 divided by P2. P1 is 1 into 10 to the power of 5. V1 is zero point 0.1. P2 is 6 into 10 to the power of 5, and you get V2 as 0.016 meter cube. Cylinder contains 0.45 meter cube. V1 is equal to 0.45 meter cube of gas at 1 bar. That means P1 is 1 bar. 1 into 10 to the power of 1 into 10 to the power of 5 Newton per meter square at 80 degrees Celsius. T1 is equal to 80 plus 273, it is 353 Kelvin. And the gas is compressed. That means the process is compression process at a volume of 0.13 meter cube. Look at the volume. Volume is decreased. It's a compression process. Therefore, pressure should increase. P2 is equal to, yes, 5 into 10 to the power of 10 to the power of 5 Newton per meter square. Yes, pressure is increased. Determine the mass of the air and value of index N and work done. As they have given index of compression here N value, therefore I can tell it is a problem of a polytropic process. If I write a PV diagram, it's a curve, polytropic process. It's a curve in a PV diagram. It's a compression process. This will be state 1 and state 2. This is P2 and this is P1 and this is corresponding volume V2, V1. Area below the curve in a PV diagram it is work done. Curve governing law PV to the power of N is equal to C, where N we have to find. Let us calculate one by one. First it is mass of A, give a notation M. For thermodynamics is based on two assumptions, reversible forces and another one which was the gas, it behaves as a perfect gas, obeys the perfect gas law. And here what the perfect gas law says, it is PV is equal to MRT. Therefore, I can write it for initial state P1 V1 is equal to MRT1. M is equal to 10 kg is equal to P1 divided by R Kelvin. Then R should be in joules per kg Kelvin. Kelvin cancels and is meter square meter. That means this is Newton meter. This Newton meter and joules cancel and this kg will come up. The unit will be kg. Therefore, pressure you have to keep it in Newton per meter square, volume in meter cube, and R in joules per kg Kelvin, and temperature in Kelvin. Therefore, mass is equal to P1 V1 divided by R T1. Pressure you have to keep it in Newton per meter square, volume in meter cube, and R in gas constant, that is joules per kg Kelvin, and temperature in Kelvin. Now what is this R? What is this R? R is the gas constant, and gas here it is we have taken it as a air. Therefore, how much is the R value for air? We know universal gas constant or universal gas constant R naught. That is R naught is how much? You know that 8.314 kilojoules per kg Kelvin. Now how to calculate R? That is R naught divided by molecular weight of which one? This is R of air. This is molecular weight of air. How much is the molecular weight of a air? The molecular weight of air is 29. Therefore, R of air it is calculated by 8.314 divided by molecular weight of the air is 29. Therefore, it is 0.287 kilojoules per kg Kelvin. This is R for air. Remember this. Therefore, after substituting here, m is equal to P1. P1 is 1 into 10 to the power of 5 Newton per meter square, and volume V1 it is 0.45, and R for area it is 0.287 into 10 to the power of 3. I said it is, you have to keep it in joules. Here it is in kilojoules. Therefore, I convert into kilo into joules. Temperature in Kelvin, that is 350. Therefore, you get a mass. Mass is equal to 0.445 kg. This is the mass of the air. The next it is we have to calculate, that is index of compression. Index of compression, that is N, as it is a polytropic process, that is PV to the power of, as it is a polytropic process, PV to the power of N is equal to C. I can write P1 V1 to the power of N is equal to V2 V2 to the power of N. Therefore, I can write in the form of ratios, that is pressure and volume ratios, that is P1 by P2 is equal to V2 by V1 whole to the power of N. Now, taking ln on both the sides, that is ln P1 by P2 is equal to ln V2 by V1 whole to the power of N. Now, ln, you know this value P1, P2, V1, V2. Only unknown term here it is N. uh, P1 by P2 is equal to, if I apply the logarithmic rule, that is ln into n into ln V2 by P1. Ln P1 is 1 into 10 to the power of 5, and P2 it is 5 into 10 to the power of 5, and n ln V2 it is 0.13, and V1 it is 0.45. Only unknown term here it is n. You can substitute it and get the answer of n, where n you will get 1.2971. Then governing law becomes PV to the power of 1.2971 is equal to constant. This is the polytropic process governing law. Now the last one, it is work done for a polytropic process. Therefore, work done for a polytropic process is given by W1 to 2 P2 V2 minus P1 V1 divided by 1 minus n. P2 it is 5 into 10 to the power of 5. V2 it is 0.45. Sorry, V2 it is 0.13 minus P1 is 1 into 10 to the power of 5. V1 it is 0.45 divided by 1 minus, what is n? How much is n? 1.2971. N is 1.2971. Therefore, after substituting all this work done, you will get minus 67.31 into 10 to the power of 3 joules. Is minus 67.31 kilojoules. The negative sign indicates it is a compression process. We calculated mass, we calculated index of compression, then we calculated the work done.